Hello everyone, we are Team 54. Our project is Who Are You, which is a data center security system mainly focusing on rack level security. Our members are Duran Liu, Minju Liu, Miao Xie, and Boyang Zhang. Our advisor is Dr. Hannah Godrich.
First, I will talk about the background. Before, in data center security, people focused on keeping people out, which means focused on regulating access to the data center. Once the person is authorized, he has the access to the data center. There will be no monitor on what happens inside. So, the remaining problem is the risks from within, especially for large data centers. First is the human error, like the person is authorized, but he opens the wrong rack. This is still one of the major causes of downtime in data centers. So it's no longer enough to just verify the authorization to enter the data center. In our project, we mainly focus on rack level security. We will track and monitor users' access to system and ensure that they access the specific rack. Also, we would provide an audit trail. Next is our original scope of work. Users first need to log into our web application, which is the building management system, and reserve for the corresponding rack and time. Here, BMS will get this information. When users go to the data center in the appointment time, first the Pi camera will open and get the face picture, sent to Raspberry Pi and compare with BMS to do face recognition. If succeeds, the Arduino will get the information from RPi by serial port communication and automatically open the corresponding rack lock. We will use door sensor to monitor the duration time. If face recognition fails, user would go to the building management manager to check identity. When verified, manager will give user RFID card which has the access to the rack.
Here is our block diagram. For the software part, we provide an interface for users to log in and make requests. The administrator can manage user information and monitor rack status. For user authentication, we provide face recognition, which is implemented with Face++. All the data is stored in the database and is shared with Raspberry Pi. The RPi controls the racks with Arduino, and we have sensors to monitor its status. Normally, if it's open or not. So once you go in and wake the RPi, it takes a picture of you, sends it to the Face++, compares the results with stored data, and if you are authorized, it will automatically open the rack for you. Since you have made the request, so you are never able to open the wrong rack.
So now I'm going to introduce the general image of our project design. First, we have three main features: the face recognition part, the RFID authentication, and the building management system (BMS). Um, so face recognition and RFID authentication is used together to authenticate the user's identity. So the main authentication is actually provided by face recognition, which we achieve it by sending the face recognition information get collected by the Raspberry Pi camera to a web API, and it will send back a face token, including our face information, and we store that token into our database. And RFID authentication is provided as a auxiliary method to allow the users to get access to their rack without passing the face recognition. And building management system is provided for administrator to remotely monitoring the status of the rack and users. Next, the implementations. So for software, we first build a web page as an interface for users to log in or sign up or making a request to the rack. Then we build a database to store the information of users and at the same time allow administrator to arrange the information. And for hardware part, we use a Raspberry Pi and Arduino to control the rack lock and manage the information sent from the BMS. And finally, for tools we are using, for sure we're using Python to program our Raspberry Pi, and we actually use C to program our Arduino. And we use MyCircle to build a database, and also JavaScript and combined with CSS and HTML to build our web page. So this is the general design of our project.
Here is a short demo of the web app. So this is the home page of our system. Now let's get started. First, I'm gonna sign up for Professor Hana. And input her email. Submit. Here's a login page, and I'm gonna log in with my own account. So this is the user page, and here shows the basic information of our system. And this is my own profile. Right now it just shows my name and email. Let's get back. So the main function provided for the user is to schedule access to the rack. Now let's make a request. If I want to open rack 2, and I choose the start time and end time. And type in some comment. Okay, we have made a request, and later we will show you how we're gonna open the rack. Now we log in as the administrator. Because it has different interface and more authorities. Here's a list of the users. You can see Professor Hana we just created. And if you want to see more information about her, just go to her profile. But we don't have her photo right now. We need to upload her photo here, and the server will generate a face token for her. Generally, only the administrator can register face information for users. These users with photos have got their face token and can open the rack with facial recognition. You can also monitor the rack status, if it's open or locked, and its location, and all the requests they have made.
Okay, so I'm going to introduce the face recognition part, and it is implemented in the Raspberry Pi by Python. So we input all our commands in the terminal. First, we open the terminal, and we go into the repository of our project, which is capstone, and we put all our Python code into a main py file, and we execute Python the file, and the system is activated. Now we're gonna input the command open to open the face to activate the face recognition. As you can see, input the open in the terminal and enter the command. And you can see that the system is now activated, and it tells us to look at the camera. So I'm going to put my face in front of the camera, and the face recognition process is started. So after the camera collects my face information, it will send to the BMS and compare with the face token we store in the database. And it's waiting for authentication. Once it succeeds, it will send back information to us. And you can see it is the face recognition is successful, and it sent back a message: welcome the user's name, and I have the access to the rack 2 and from the time that is given, and we send the command to the Arduino, and Arduino open the lark, and the system is ready again. So this is the process of the face recognition. Thank you.
Okay, so next is RFID authentication part. First, we will also run the code to get ready for the system. After that, we need to type open as a signal to activate the system. After the system is activated, we will also do the face recognition part. But this time, because my face is not in the database, the authentication will fail. So it says authentication failed. You may scan authorized card or try again. So this time, I will try to scan my Apple card. So after scanning, you can see from Arduino, rack 1 is unlocked by RFID authentication. That's the first part. So next, I will try to show you another scenario when the real user to use an authorized card to try to open this rack. So after the face recognition, it's also failed, but this time you can see Arduino says your card is not authorized. You may try again. So next is another scenario when another person try to unlock another rack. Let's say the user want to unlock the rack 2. So when activate the system, this after the failed face recognition, we will try to open another scan another card, and you can see from Arduino that rack 2 is unlocked by RFID authentication. So that's the whole part of RFID authentication. Okay. So the next is future work of our system. The first two parts is due to the current situation. We can implement all the hardware part we prepared in priority. So we will try to implement this system in a physical lock on the physical rack. Also the door sensor, we need to solder every part together to monitor the state of the door. And also we will continue to improve the UI design of the web to make it more friendly use or easier to use. The next part, we will try to develop the mobile app for our BMS. Because the smartphone has most of smartphone has NFC features, we can try to add some virtual card to the to the mobile phone, and try to scan the mobile phone to be the RFID card, and then open the related racks. The last thing is we will try to continue to minimize the cost of the system and make it more easier to implementation. So that's the whole project. Thank you.